Hey guys, today we're going to take a look at graphing square root functions. So we're going to be talking about a different type of function that we have not done this year, and you need something to write with, your graph paper notebook, so a place where you can make quick graphs, and a calculator. Let's review some of the general things we've already talked about this year in terms of our functions. We've already graphed things that were y equals x squared. Those are our parabolas, our quadratic functions. Then we talked about our absolute value functions. Those made a V shape. We've also talked about linear functions, y equals mx plus b. And then anytime our exponents there became higher than 2, 3, 4, 5, so x to the fifth, x to the fourth, x to the third, those were our polynomial functions, and we called them our roller coaster graphs, and we had arrow end behavior and numbers of turns and multiple solutions. So these are all the types of functions that we've talked about. Notice they all have a general look. The same is true for the square root function. So we're going to start with the parent square root function, so the general square root function first, and then we're going to move him around on our graph. So y equals the square root of x. Remember, when we go to graph, we're going to make a table, or we start by making a table of values. So usually we would choose some negative values, 0, some positive values, and so on. Now when I go to plug in these values, watch what happens. If I take negative 2 and I plug them in, can I square root a negative 2? No, it's not real. It's imaginary. You can't square root a negative number. So that can't be a value that I use in a table. Same thing if I plug in negative 1. I can't use that one in my table. The very first one that I can plug in is 0, because I can square root 0. The square root of 0 would just be 0. The next one, square root of 1, would just be 1. Square root of 2 would be 1.4. This is where your calculator comes in. The square root of 3, approximately 1.7. And the square root of 4 is 2. Now if I go to make a graph over here, and you should do this, okay, make a graph, sketch x and y, and then plot those points. This is what you should see once those points are plotted. You should see an actual starting spot at 0, 0, and then the graph continues in that direction. There's 0, 0, 1, 1, 2, 1.4, 3, 1.7, and 4 is up at 2. So plot those points, and it makes this curve, okay, and it has a starting spot at 0, 0. That restricts our domain and range a bit more than what we're used to. So my domain is x has to be greater than or equal to 0. I couldn't compute any of those negative values. And then my range is a description of my y values. My y values start at 0 and they're getting bigger. So my y values greater than or equal to 0. So we are going to take this parent function now and apply some shifts to it. Now let's remember back to our shifting that we've done before with parabolas. Remember, the parent parabola was located with vertex at 0, 0. And then if I put a negative 8 at the end, or I subtracted 8, this moved it down 8. If I put a negative in front, that was a reflection or a flip. Flipped it over. Inside the original function here, or inside the square, this moved it left or right. So this was a left 6, and then we did multiple things to it, like this one where we went right 4, up 5. So the same sort of shifting rules apply again to square root functions. I made a little box down here for things that I think you should write. So if we have a number at the end, so that's a vertical shift. It's outside the main function. It moves it up or down. If there's a number inside the square root, like this h, that's going to move it left or right. Many times there'll be a number out in front. That's going to vertically stretch the function or compress it. And then if there's a negative out in front, that's going to flip the function over or reflect it. So let's use that shifting idea on these two examples that we're going to do, and it'll help us set up that table a little bit quicker. So this one says g of x equals the square root of x minus 3 plus 4. So if I was going to use my shifting rules, inside this is telling me I'm moving to the right 3, and then out here is saying I'm moving up 4. So if I move to the right 3, up 4, this is the absolute first spot I can ever calculate in my table. So that is located at 3, 4. So my XY table needs to start with 3 and 4. X value of 3, Y value of 4. So now if I continue a list of X values beyond that, 3, 4, 5, 6, 7, and so on, 8, however many you need there, then we should be able to plug those in and figure out the corresponding Y values. So if I were to plug in the 4 here, 4 minus 3 in absolute value, plus 4 at the end. 4 minus 3 is 1. The square root of 1 is still 1. Plus 4 makes 5. So the Y value for that one is 5. Then I'll go plug in a 5. 5 minus 3 plus 4. 5 minus 3 is 2. Square root of 2 is 1.4. Plus 4 makes 5.4. Then I'll plug in 6. Square root, or 6 minus 3 is 3. Square root of 3 is 1.7. Plus 4 makes 5.7. And then I'll plug in 7 here. 7 minus 3 plus 4. 7 minus 3 is 4. Square root of 4 is 2. Plus 4 makes 6. I think you get the idea. So we can go ahead and continue plugging in these XY values if we want to, or I'll just sketch what we have now and see what kind of shape we have. So 4, 5, 5, 5.4, 6, 5.7, 7, all the way up to 6. So we go ahead, we can sketch that, and you can see it has the same general shape as the parent function, which is what we want. So domain and range now again come from what x values and y values we could have. X values had to start here at 3. So x has to be greater than or equal to 3. My y values, because x started at 3, my y values also had to start at 4. So my y values are from 4 and up, so y is greater than or equal to 4. One more example here with another shift, and then we're done. Example 2, this one has a negative in front of the square root sign, and then minus 1 at the end. So let's use our shifting rules. Inside, left 2, down 1. Left 2, down 1 puts me there. So negative 2, negative 1 for the very first x and y values in my table. Now remember, the other clue in this one is that negative out in front. That's a reflection. That means he's going to flip the graph over. So if it was a graph that looked like this, like square roots do, now my graph is going to look like this, flipped over. Okay, so we should expect that sort of shape. So let's choose more x values here to plug in. So negative 2, if I get bigger here, negative 1, 0, 1, 2. If I start increasing, 3, 4, okay, however many you need there. And then we'll go ahead and plug these values in. So I'm going to plug them in kind of to the side here. I'll have a negative. I'll plug in negative 1 first and work from my inside out. Inside here turns into 1. The square root of 1 is 1. Put a negative back on it, it becomes negative 1. Negative 1 subtract the 1 at the end becomes negative 2. So negative 1, negative 2 is the next value in my table. Plugging in 0. Negative sign, 0 plus 2, minus 1. So inside first, 0 plus 2 is 2. Square root of 2 is 1.4. Negative on it is negative 1.4. Minus 1 more makes negative 2.4. So 0, negative 2.4. Now we'll plug in 1. This turns into 3. The square root of 3 is 1.7. Put a negative sign on it. It's negative 1.7. Minus 1 makes negative 2.7. So at 1, I'll go down to negative 2.7. Plugging in 2. And I think this will be the last one since you probably get the idea. Inside the square root is 4. Square root of the 4 is a 2. Put a negative sign on it. He becomes negative 2. Minus 1 more makes negative 3. So 2, negative 3. So this starts at our beginning spot in our table and is reflected like we anticipated. So he's flipped over. Let's describe the domain and range. X, y. The x values start at negative 2 and get bigger. So negative 2, x is greater than or equal to negative 2. Let's talk y values. Y values are starting at -1, but watch out, because he's reflected, they're actually decreasing, they're getting smaller, so y's are less than or equal to -1. So domain and range restrictions happen on our square root graphs, and we need to think about that as we're graphing. Thank you for taking good notes.